Okay, so we're going to talk about ellipses. So remember, ellipses are the set of all points that are the equal distance from the foci, meaning that as we move this point here on the foci from side to side, the pieces will be equal to one another. Okay, the major axis is going to be where those foci lie. And so that's that C piece that we're talking about, okay? And the minor axis will be the shorter axis of symmetry there. The two equations we have to have memorized are the horizontal ellipse and the vertical ellipse. Okay, so they're here. And the key from this is that the A value is always underneath whichever type of ellipse it's going to be. So the A value here is underneath the Y, and then we have the A value here underneath the X. So if it's underneath the X, it's a horizontal. If it's underneath the Y, it's a vertical. The A value is always the bigger number. Okay, so it's always larger than the B value. So that's what gives it away. Our center is coming from H and K, and those are those numbers that are going to be in the equation there next to the X and the Y. Notice that it is a minus, so when we take the center point, it's actually the opposite of. So it's negative H up here, and it's actually a positive H here. When finding the foci, okay, on a horizontal ellipse, it's H plus C, H minus C. Okay, because things are being affected on the horizontal axis there. For vertical, it's going to be K plus C and K minus C because those are being affected on the Y since it's vertical. In order to find C, we use the equation C squared equals A squared minus B squared. Now this will be different when we talk about hyperbolas, so please make sure you know that A squared minus B squared equals C squared is for the ellipse. And when we're talking about solving using the pieces, we need this equation a lot. Okay, now let's look at graphing. That was the first thing we looked at. Right, we have to remember our equation here, and if you need to write it again, please do. X minus H squared over A squared plus Y minus K squared over B squared equals 1. Now I chose to put the A squared here underneath the X because I saw that my bigger number was 25 and that it was underneath X. Okay, so this is a horizontal ellipse. Okay, so my center point is going to be 3 because that's the number next to the X. There's no number next to my Y, so it's 0. Okay, and I'm going to plot that at 3, 0. Okay, my A value is going to be the square root because this is A squared, 25 is, so I'm going to take the square root of 25 to get 5 for my A value. I'm going to take the square root of 9 to get my B value, which ends up being 3. And these are the distance that I'm going to be moving vertically and horizontally. The A value was underneath the X, so I'm going to be moving horizontally 5 in either direction. Okay, and then I'm going to be moving 3 in either up or down. 1, 2, 3. Okay. And then I kind of suck at free drawing, but there's my ellipse. Okay. Um, in order to get the foci, I need to use that equation c squared equals a squared minus b squared. Okay, I know that my a squared was 25 and my b squared was 9. Okay, so that makes my c squared equal to 16 and my c equals plus or minus 4. Right, because I had to take the square root of both. Okay, so when I am plotting these on here, okay, I'm going to take plus or minus 4, and because this was a horizontal ellipse, I'm adding it to the x value from my center point. So it's going to be 3 plus 4, comma 0, and 3 minus 4, comma 0. Okay, so 3 plus 4 is 7, so I have a foci at 7. And then 3 minus 4 is -1, so I got a foci there at -1. Now, the closer this ellipse gets to being a circle, the closer the foci get to the center point. The skinnier the ellipse gets, the further out the foci will get. Okay? Again, remember, the C value here is what we are adding and subtracting to the original center. Either it's X or it's Y, depending on if it is a horizontal or a vertical ellipse. Okay, I want you to go ahead and try this one on your own, and you can check the key on Blackboard to see if you did indeed get this one right. Okay, now we're going to look at being given a graph and writing the equation from that, right? So these are the 3 things that we need to find. We need to find the center, we need to find the major axis, not the full length, but half of the length, and then we need to find the minor axis and half of that length. So when we're talking about the length from the major and the minor axis, we're talking about the length from the center point to the outside of the circle. When they give you problems that have the full major axis length, they're talking about from endpoint of the ellipse to another endpoint on the ellipse. Okay, so then that's when we're going to take that half. So looking at this picture, right, the center here is at 0, 0. Right, it's halfway between everything there. So my center is 0, 0. My major axis, right? This is clearly a horizontal because it is more football shaped. Okay, so horizontally from my center point out to the end of my ellipse, I've gone out 5. Right, so that's my A value. But in my equation, I don't need A, I need A squared. So if I square 5, I get 25. Okay, my minor axis is the vertical axis, okay, and I've gone up 2 from my center point, so that makes B squared 4. Okay, now this is where you have to remember what the equation of a ellipse is, and I strongly suggest making note cards so that you can practice it. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. Now I gave you that one again because this is the horizontal. And if you have a vertical, right, it would be the a under the y. So my center was 0, 0, so I'm not adding anything to my x, so it's just going to be x squared over my a squared of 25 plus y squared over 4. And it's going to equal 1 always. Please do not forget the 1. If you're forgetting the 1, you're not writing an equation. Okay, you need the 1 there. Now again, if we were trying to find the foci here, okay, we would use a squared minus b squared. So we're going to do 25 minus 4, which gives us 21. And then that equals c squared. So the foci itself, we're going to be adding and subtracting the square root of 21. So c equals square root of 21, technically plus or minus, which is why we're adding and subtracting it. Okay, and again, this was a horizontal, so we're adding and subtracting it to our x value. So we would have plus or minus the square root of 21 comma 0. Okay, and if the square root of 21 is going to be between 4 and 5, so it's going to be in here. And we would plot those to the best of our abilities. I know we don't know what the decimal is exactly on the graph, but we'd plot those to the best of our ability. Okay, this one is a vertical, okay, so it's going to be a little bit different. We're going to have our center, right? I'm looking at this and I like can't exactly tell, but I'm thinking it's going to be about here. But let me double check that both are even. So if I go up, I've gone up 1, 2, 3, 4, 5, and I've gone down 1, 2, 3, 4, 5. Okay, so I found my center, and it is at 3, 2. Okay, my major this time is vertically, and I found that again it was 5. So a squared is 25. And if I go for my horizontal, it's 2. So b squared is 4. Okay, now this time again it is a vertical. So my a value is going underneath my y's. Now you can write x first, you can write y first, it does not matter. I'm going to do x first this time. So we're going to have x minus 3, remember it's the opposite of the sign, over b this time because a is not under x, so under 4 plus, don't forget the squared, y minus 2 squared over 25 equals 1. Now these are the same numbers we had last time, so it's still going to be for the foci, we're still adding and subtracting the square root of 21. But we are adding it this time and subtracting it to the y values because this is a vertical ellipse. So we would have 3 comma 2 plus or minus the square root of 21. Okay, and when we plug this into the calculator, we get about 6 point something and negative 2 point something, and we would graph those again to the best of our ability. So I would like you to please practice this problem if you need it. Take a few seconds to see if you can get it, and I'll move the slide to see if you did it correctly. Okay, if you had done it correctly there, you would have gotten this as your equation. Again, these two could have been switched. Addition is commutative as long as the 25 was under the y and the 1 was under the x. Okay, so let's talk completing the square. When completing the square, we want to move the constant numbers to the right side, and we want to move all of our variables to the same side and put them in a nice order. So I see that I have an x squared. Okay, so I'm going to move my x squared with my 6x. And then I know that I'm completing the square, so I'm going to keep a space. Okay, then I'm going to move my y's together, so I have plus 4y squared minus 16y. I'm going to leave the space because, again, completing the square. And I'm moving my 9 to the other side, so when I move it to the other side, it becomes negative. The biggest thing that happens is sometimes when we move this piece to the other side, we keep the sign the same. Remember, you have to switch the sign. Okay, so the leading coefficient in front of the x is 1. That one is great. The leading coefficient in front of the y is a 4. I can't have that 4 there. I need to factor that 4 out. So I'm just going to rewrite my x's because those are fine. I'm going to leave my space for completing the square. And now I'm going to factor out a 4 from all of my y's. So 4 divided by 4 gives me the 1 there, so I just have y squared. And 16 divided by 4 is 4, so I have negative 4y. And then I'm going to leave a space there for completing the square, and it's still equaling that negative 9. Okay, I'm going to change colors so we can really see what numbers we're adding in, and I strongly suggest that you do the same. So to complete the square, okay, we're going to take the middle term of this trinomial that we're trying to make, okay, and we're going to divide it by 2. So we're going to take negative 6, divide it by 2, and we're going to square it. Okay, so when we do that, we get a positive 9. Okay, now we didn't multiply this by anything out in front, so we're adding 9 to the right side too, because you can't just add something in. All right, now we're going to complete the square for the y's, and here we have a negative 4. So we're going to take negative 4, we're going to divide it by 2, and we're going to square it. Okay, when we do that, we get a positive 4. Now, most of us will want to write 4 onto this side over here, but we cannot do that. We didn't just add a 4 to the equation. We added a 4 times a 4, which is a positive 16. Okay. Now we're going to factor each of our trinomials. So here, our first one with the x's, you write x, you keep the sign that is in front of the middle term, and you divide that number by 2, which is 3, and then you put it in parentheses, and you square it. This is because it is a perfect square, okay? And then we're going to add our y's. The 4 is still out front. It doesn't go anywhere. We just bring it down, okay? And then we factor this piece here. So we do exactly the same thing. So it's going to be y, keep the sign, okay, and then divide by 2, which gives us 2, and then we square it. And it's going to equal 16 over here because those 9's will cancel. Now when we're solving for ellipses, we have a 1 on the right side. So we're going to divide everything by 16. Okay, so we're going to get x minus 3 squared over 16 because there's nothing to simplify there. There wasn't a number out in front. Now we have a number 4 out in front here. And we're going to simplify 4 over 16. And when we simplify 4 over 16, we're left with a 1 in the top. So it's just y minus 2 squared over 4 and 16 would give us a 4 on the bottom, and it equals 1. And now we have our perfect ellipse equation there. And this would indeed be a horizontal ellipse because the 16 is the biggest number and it's under the x. Okay, I want you to give this second one a shot. Okay, try it on your own and I will have it worked out for you. Okay, so here is what you should have gotten. X plus 5 squared over 36 equals y plus 5 squared over 144 equaling 1. Okay, I will put up another one as your practice. If you want to check with me in class, you can see if you had gotten that correct. Feel free to pause the video, work it out, and bring it in and see how well you did. Okay, so let's talk about finding the equation of ellipse from pieces given. You can always, always, always use graph paper to help you solve these problems. Okay, so they tell us that the major axis horizontally has a length of 8. Again, the major axis, okay, and its length is going to be from endpoint to endpoint of our ellipse. So it's going through the center point. And we know that the center is at 0, 0. So let me plot the center here at 0, 0. And we know the full length horizontally is 8, which means from the center, we've gone out 4 in either direction. And that 4 value is our A. So we get A to be 4. Okay, so major axis lengths give us A values. Right, and we always end up taking, right, 4 is half of the 8. So we take half of the full length. Okay, the minor axis gives us our B values. Okay, and it was a full length of 4, which means we've gone up 2 and down 2 in either direction. So our B value is 2. Now we have all the pieces we need, right? Every time you do an equation like this, please make sure you find the center and then your A squared and your B squared. Okay, those are the pieces we need to make the equation. And again, if you do not have the equations memorized, you need to do so. It's x minus h squared over either a squared or b squared, depending on if it's horizontal or vertical, plus y minus k squared over either a squared or b squared, depending on if it was horizontal or vertical, and it always equals 1. So here, our center was 0, 0, so I'm just writing x squared and y squared. Okay. And I know it equals 1. Now the bottoms I'm going to get from my A and my B, and we said this was indeed a horizontal, so the 4 squared is going under the x, okay, and the B squared is going under the y, and now I have my equation. All right, let's look at another one. This time they give us the major vertices. So plotting these on my graph here might not be helpful to me because I don't actually have negative 11 and positive 11 on my graph. But I can get some really valuable information from just the points without graphing them. So I'm going to do this one without graphing. But again, if you need the graphing, please do so. Please find a piece of graph paper and graph it out so that you can see it. So again, we need our center point. Oops. Okay, so I'm going to find my center first. Okay, So if I look at my major and my minor vertices, I will notice that there are numbers that do not change. So in my major vertice here, the 6 did not change. So I know the 6 will be part of my center there and the x. And then here the -3 on the minor did not change. So -3. Now I have my center. I still need to find my a value and my b value. Okay, so I get my A and my B values from what is changing. The major always gives you the A values. Remember that. The major is always the A. So now I'm going to look at the pieces that I have left. I have 5 and I have -11. So what is the distance between those points, right? So from 5 to -11, I have moved 16, right? 16 spaces. So that means the full length from endpoint to endpoint of this ellipse that I have, like this, is 16, right? I don't want the full length. It's like the diameter of a circle. I want the half. So I'm going to take that 8 and I'm going to divide it by 2. Okay, so I found the distance between 5 and -11. Okay, so 5 minus -11, right? That ends up being 16. That's the full length, and I'm going to divide it by 2, and it gives me 8. That will be my A value. Okay, I'm going to do the same thing for the minor. Okay, so I have 11, and I have 1. So 11 minus 1 is 10. And again, that's the full length from the top um, from like endpoint to endpoint, right? It's actually not going to be top and bottom, but from endpoint to endpoint. And then I'm going to divide it by 2, and I get 5. So my B value is 5. Next, I determine whether or not it's horizontal or it's vertical. So looking at the numbers that I have boxed in on the major axis, it is my Y values, which means my Y was what was changing. So this makes it a vertical ellipse. Okay, so my A value is now going underneath my Y values. Last step, write the equation. So x minus 6 squared. Now again, we said this was vertical, so it's going to be 25, that is under the x value. And then I'm going to be adding it to my y plus 3 squared under my have my A value of 64, and it equals 1. Okay? Again, major gives us the A, minor gives us the B. Determining what changed gives us whether or not it's horizontal or vertical. All right, let's look at one last example, this time with foci. Remember, foci always represent C values. And if we have a C value, it means we need to use that equation, C squared equals A squared minus B squared. Sorry, that 2 does not look much like a 2. Okay, and then the major vertice again gives us the A value. So if I plot the points -5 and 0 and 5, 0, and I find the center, which ends up being for us 0, 0, okay, because it's the one that's in between the two. I now have my center point, right? So I'm going to write that down so I remember it. Center is 0, 0. All right. So the distance from the center out to my foci gives me C. So C is 5. Now you can figure this out without actually graphing them by seeing the distance between the two and dividing by 2 as well, whichever one works for you. Okay, and then the major vertices are at -8, 0, and +8, 0. So that gives me my A value of 8. And now I need to use this to find b, because remember, we need a squared and we need b squared for our equation. So we're going to say that 25 equals 64, because that's our a squared, minus our b squared, which we're looking for. Subtract 64 from both sides, and we're going to get negative 39 equals negative b squared. So b squared is positive 39. Now all we need is b squared, right? We don't need the square root, so we can leave that as 39. Now we have all of our pieces and we just need to write our equation. So again, our center was 0, 0, so I'm just going to be writing x squared and y squared. So x squared plus y squared. And then underneath is going to depend on whether or not it's a horizontal or a vertical. Looking at the foci, we can always determine which one was on the major axis. What changed? It was our x values, right? Our x values changed. So that means this is a horizontal ellipse. Okay, so I'm going to now put my a value of 64, right, my a squared value of 64 underneath my x's. And I'm going to put my b squared value of 39 underneath my y's, and I'm going to set it equal to 1. Okay, I'm going to put up another problem for you to practice on. So please give this one a shot. And I will post the answer here in a couple seconds and see if you got it right. Feel free to pause the video and see if your answer matches the answer that is indeed on the board. All right, and here is what you should have gotten. If you're having more questions on this, please feel free to come and ask. I have Bear Blocks Mondays and Wednesdays.